A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with two more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe.
Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Zanclean Flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these two bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Messinian Salinity Crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. You would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder. What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zanclean flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent, in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too. Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought.
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamelt, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front-row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking axial instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in axial eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale. On January 14, 2022, residents of Anchorage, Alaska, heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away, in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then, it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research model showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor, equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions.
Not an earthquake, but a mega-earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega-earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega-earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega-earthquake can happen, underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega-earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe, a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega-earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega-earthquake and a tsunami is about 80%. Over the past 1,400 years, mega-earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega-earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes. hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation. But the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors. Be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors, and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the third floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing.
An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground. But there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning. which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of three main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Euclid wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the waves surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happened not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger. which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Massive tsunamis, destructive tornadoes, giant meteorites, devastating earthquakes. Ooh, better have insurance. But all these are minor natural disasters compared with the eruption of a volcano. Some volcanoes can destroy a city, as it was with Pompeii, or some islands in the Pacific Ocean. But there's a dangerous type of eruption that can destroy all life on the planet. This type is called flood basalt. But first of all, let's figure out what a volcano is. Rivers of hot liquid metals and incandescent rocks flow deep inside our planet. And the deeper it gets, the hotter they are. The source of this hot mass is the mantle, which is the middle layer of Earth, located between the core and the crust. These fiery streams are called magma, and it flows everywhere. But we don't feel its heat because of the thick layer of our planet's crust. Magma is lighter than the crust, so it always tries to break out to the surface. And in some places, it succeeds. At the junctions of tectonic plates, it splashes out when one plate moves under a thicker one. When magma reaches the surface, it becomes lava. This substance burns the ground around and cools down quickly. It hardens and forms a new layer of rock. The following splash of magma falls on the top of this layer. Thus, a mountain appears layer by layer over millions of years. And in its mouth, a fault of tectonic plates splashes out magma. This mountain is called a volcano. It spits lava and ash into the sky, then falls asleep and wakes up again during seismic activity. Now imagine that several giant volcanoes begin to splash out an infinite amount of magma. It just doesn't end and covers an entire continent. This is a flood basalt, and one day it did happen. About 252 million years ago, in the northern part of our planet, a lot of magma accumulated under Earth's crust. Trillions of tons of hot rock were concentrated in one place on a gigantic territory. And gradually, all this fiery energy began to seep out of the ground. Hot gas started to come out in different places in this territory. The ground shook endlessly, and the crust rose hundreds of feet, all pointing to the approach of an imminent catastrophe. And then, at some point, magma began to pour out. Giant fountains of fire burst out of the ground. Do you know these geysers in Iceland? So imagine the same things, but dozens of times higher and with hot lava and ash instead of water and steam. The ash and lava flows were so strong that they reached the clouds. Under Earth's crust, there was a gigantic bubble of magma, and it squeezed out fiery jets under the pressure of rock and ground. The rift was getting bigger. Magma was flowing out everywhere. It began to fill the entire North Continent. The flood of lava spread wider and wider. The streams of molten rock seemed endless. Layers of molten basalt rock overlapped one another, forming a giant tsunami of lava 160 feet high. It poured out of the ground for hundreds of thousands of years, flooding forests, rivers, lakes, and meadows. At the same time, billions of tons of volcanic ash rose into the sky, which could lead to a volcanic winter, since sulfur dioxide in the ash reflected the sun's rays. This might have lowered the temperature on the continent by several degrees. Then, dust and ash probably condensed and formed giant clouds that watered the surface with toxic acid rain. But after that, the cooled lava formed a giant thick shield, preventing magma from seeping out of the endless fire bubble. The global catastrophe was over, but only for a short time. Trillions of tons of magma were still flowing under a thick layer of solid basalt. The fiery rivers couldn't reach the top, so they spread out to the sides. As a result of this expansion, huge nets were formed under the thick rock. They ran in different directions like a spider web and heated Earth's crust. Gases started coming out from under the surface again. More and more energy accumulated there until an explosion of unimaginable force occurred. In addition to magma, carbon dioxide and ash escaped to the surface. They filled the atmosphere and caused the greenhouse effect. The temperature on the whole planet increased by several degrees. This release provoked another catastrophe that began in the ocean. There were deposits of methane, an explosive gas, on the seabed. Under ice-cold water, the methane was frozen and harmless. But the greenhouse effect in the atmosphere warmed up the entire ocean. Millions of tons of methane began to rise to the surface. This gas is more potent than carbon dioxide. Therefore, when it hit the atmosphere, the temperatures on Earth increased again. The whole globe turned into a hot sauna. In previous cool and humid places, the temperature reached those of a modern Sahara. Of course, most animals and insects couldn't survive such a cataclysm, but ocean life took much more damage. The heat and methane reduced the amount of oxygen in the ocean. Fish and other marine life couldn't survive in such conditions. New problems appeared when anaerobic bacteria started to multiply in non-oxygen water. They fed on methane and carbon dioxide and released hydrogen sulfide, a toxic substance that poisoned water even more. About 75% of land animals and 95% of the ocean's inhabitants went extinct. This flood basalt eruption was the only disaster in the planet's history that destroyed almost all plants and significantly reduced the insect population. Several species of the hardiest animals managed to survive in these conditions. The planet took about 10 million years to recover completely. After that, evolution began a new process of developing life. And here are two pieces of news. The bad one is that flood basalt will happen again and will be no less devastating than 252 million years ago. The good news is that it will happen in hundreds of millions of years. But when that happens, humanity will need to be prepared. It will start on the ocean floor. First, lava fountains miles high will begin boiling the water and emit sulfur dioxide into the atmosphere, where it will reflect sunlight. Along with ash and magma, a massive amount of water vapor will rise into the air. Livestock won't survive, and people will have breathing problems. Acid rain and increased humidity caused by the evaporation of the oceans will lead to the corrosion of buildings. All flights will be canceled. People will have to wear gas masks. Many animals won't be able to handle this eruption, but humans will adapt quickly. But then another and another eruption will follow, and this endless catastrophe will soon deplete the resources of humanity. Plants and trees won't recover so fast, and oxygen production will be significantly reduced. Let's hope that humanity will have colonized other planets, including those outside the solar system by that time. And now, let's jump back to the present. About 70% of the seismic activity associated with volcanoes occurs underwater. So let's see how ordinary volcanoes on the ocean floor work. Water, as well as land, rests on tectonic plates. Therefore, if their structure is broken at the joints, magma seeps through them. But unlike terrestrial volcanoes, lava here doesn't spread in different directions, burning everything it meets. It solidifies under the pressure of cold water. Underwater volcanoes can erupt for a long time with breaks in between. Magma covers the seabed. After another 100 or 1,000 years, a new eruption begins and a new layer of rock forms over the previous one. Over millions of years, layer by layer, magma is rising. And then, one day, a volcano rises out of the water. Magma splashes out of it and increases its height. And now we have a large volcanic island. Then the volcano falls asleep and life appears on the newly formed piece of land. Magma flows from the planet's mantle, filled with various chemical elements. This hot mix saturates the soil with useful substances and thus promotes the growth of plants and trees. Then birds and other animals arrive there, and the volcanic island turns into a paradise. Then humans arrive and pave over paradise to put up a parking lot and a franchise burger joint.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh? The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario. A city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big-game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project, named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
July 17, 1998. It started like a usual quiet evening in the villages along the north coast of Papua New Guinea. Then, at 5:49 p.m., the ground shook violently. Suddenly, a 7.0 magnitude earthquake struck. It sent shockwaves through the region. Walls cracked, homes trembled, and the earth beneath the villagers' feet shifted and twisted. It lasted for 19 seconds, with a depth of 19 miles, and seemed like a typical earthquake. And while it caused some damage, this wasn't the kind of destruction that screamed doom. So, people were tricked. They thought it was over. They didn't know that the worst was still coming. Then some villagers noticed mysterious lights. It began with a flash of red light along the horizon, a streak that looked like fire. It appeared shortly after the initial earthquake, stretching across the northern sky above the ocean. It flared brilliantly, then vanished in an instant. What could it have been? People started speculating whether it's a warning about something or just sunlight reflecting strangely. But just as it disappeared, it was followed by a loud booming sound from the sea. No one knew what that meant, and some villagers went to the beach, curious to scan the views. What they noticed there chilled them to their core. The ocean looked wrong. The water wasn't calm. It churned, bubbled, and boiled in an eerie, unnatural way. That's when they saw it. A massive wave building in the distance, rushing toward them with terrifying speed. Panic spread like wildfire. People climbed trees, pushed boats into the lagoon, hoping to escape the approaching monster. Unfortunately, it was too late. The first wave hit with unimaginable force and swept away entire villages in an instant. The debris was scattered around, trees were uprooted, buildings were displaced up to 160 to 200 feet inland. Even decades later, some of these affected villages can't be accessed by roads. At the same time, another strange phenomenon emerged. Many people described a red glow at the crest of the tsunami, as though the wave carried fire in its peak. They described an eerie glow as the wave approached the shoreline, a deep and unearthly hue, visible even from far-off places like Itape. And this was only the beginning. 2 more waves followed in quick succession. The second one was the most horrifying, from 33 to almost 50 feet high. By the time the ocean finally receded, the coastline was unrecognizable. After the waves had ravaged everything, leaving villages in ruins, the sky put on one final display. Survivors described a yellow or yellow-red glow illuminating the sky over the ocean. One man who survived by climbing up a tree saw the glow lingering over the horizon, stretching toward the direction of Arap and Itape. At Malol, the Sisters of the Mission looked out to the sea and were stunned by the surreal calm of the golden water. It was still as glass and lit by this unearthly glow. The glow was so vivid, it lit up the entire devastated landscape. Luckily, this allowed survivors to begin searching for their missing loved ones. A lot of people believe these lights were supernatural, an omen of sorts. This event ended up being catastrophic, sudden, and unpredictable. The Royal Australian Air Force responded immediately, sending in planes with relief supplies. People started an investigation. What exactly caused this disaster? Turns out, this tsunami wasn't like most others. Tsunami waves are very different from regular ones. We usually imagine huge breaking waves next to the beach. But they might first look like the water is rushing away from the shore. Stay vigilant because this is a warning sign. The water will come back very quickly and rise like a massive tide, often with devastating force. Rarely they come alone. They often arrive in a series, destroying everything along the coastline. They happen when a large amount of water in the ocean or big lake gets suddenly pushed out of place. The main causes are usually earthquakes, which happen when the Earth's tectonic plates shift suddenly under the ocean. They start lifting or lowering the seafloor, and this pushes the water above it, causing huge waves. This tsunami in Papua New Guinea was completely different though. At first, scientists thought that it was caused by the Australian and Pacific tectonic plates slipping against each other. But it turned out that the earthquake itself wasn't the problem. It really was pretty small. However, it had triggered a massive underwater landslide. When the seabed shifted, it pushed away an insane volume of water. The waves reached almost 50 feet high, like a 4-story building. That's how we realized that even small earthquakes can actually cause massive tsunamis via underwater landslides. What's even worse is that tsunamis like this can happen with little or no warning, simply because the earthquake alarms don't go off. But what about that bubbling and boiling of water that people saw? Turns out, this was the release of underwater gases. Beneath the ocean floor, there are pockets of gas trapped in the sediments. For example, methane, which is often found in oil and gas fields, or hydrogen sulfide, a gas that smells like rotten eggs. During the earthquake, the seabed probably cracked or shifted, releasing these gases into the water. This caused bubbling or boiling. The water might have heated in some areas. People mentioned that the waves felt hot and even stung their skin. The chemicals in it most likely made things even worse, irritating their skin. These gas eruptions might also have played a role in making the tsunami stronger. Maybe they were the ones that loosened the sediments that caused the underwater landslide, or pushed the water up when the gas escaped. It's like shaking up a bottle of soda. If the pressure releases suddenly, it causes a huge reaction. But what about the strange lights? Well, that's more complicated. There's a phenomenon called earthquake lights. They happen all around the world, flashes, glows, or aurora-like effects. Although they're usually white, bluish, or even multicolored, sometimes these lights last seconds, sometimes up to tens of minutes, at any point in an earthquake. If we go by their description, then the first red flash could have happened because of electricity. Earth's crust is full of quartz and similar stuff that can release electricity under pressure. When the earthquake shook the ground, all that electricity traveled up into the air. Gases from before could have helped here. They could ignite or interact with charged particles in the air, making the lights even brighter. As the wave continued to churn up sand, rocks, and debris, the intense pressure and movement could have released more sparks. This could cause the fire-like lights at the wave's crest that people noticed. Finally, the yellow light could have been all these electricized gases rising into the atmosphere. Methane and other gases interacted with Earth's magnetic field and created something like aurora borealis. But these are all speculations. The most heartbreaking part of the story is that tragedy in Papua New Guinea was preventable. Scientists knew the tsunami was coming, though it arrived earlier than they expected. The first wave struck between 10 and 25 minutes after the earthquake, about 5 minutes earlier than models showed. That means that it started somewhere close to the shore. The reason no one evacuated in time was simple. Local people didn't have a tsunami warning system or even enough knowledge about tsunamis to understand that an earthquake might lead to one, or why the water was acting weird. Things like that haven't happened in Papua New Guinea in over 60 years. But this was a wake-up call. From this immense tragedy came lessons and resilience. A year after the disaster, all the surviving locals watched a documentary that explained what had happened and taught them what to do if it ever happened again. This effort saved lives because the story did happen again. A similar earthquake and tsunami struck the nearby island of Vanuatu in November 1999. But this time, the villagers were ready. They remembered what they had seen in the film. Instead of panic, they acted quickly, and luckily, hundreds of lives were saved. Now, tsunami warning systems are everywhere in developed areas. They can send alerts to people via sirens, text messages, or broadcasts as soon as a potential tsunami is detected. Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise! It's a volcano! But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone. But Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo. And with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, Wow, this place is paradise. Just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy.
Doggerland? No, it's not a country of dogs, as you probably first thought. It's a land the size of Great Britain in the north of Europe. But don't bother trying to find it on the map of the old continent. Your search will come back empty. Doggerland hasn't existed for thousands of years. But where was it exactly? And did humans live here? Scientists are doing their best to answer these questions. Let's start with the name. In the 1990s, a British archaeologist named the area Doggerland after Dogger Bank, a sandbank some 60 miles off the east coast of England. The word probably comes from Dutch. It was used for a fishing boat with 2 masts. Makes sense, since today, the North Sea is a rich fishing area. But thousands of years ago, people living here had a different diet. Some 12,000 years ago, the last major ice age was slowly reaching its end. Doggerland didn't feature seawater, but marshlands, lagoons, forests, and gently sloping hills. At that time, Britain and Ireland weren't islands. They sat deep inland. You could set off in Denmark and walk all the way to the north of Scotland. There was a system of rivers that emptied themselves in the North Sea. Back then, it was more of a channel that separated Doggerland from Norway. The rivers were different too. The Thames flowed into the Rhine. The ancient river they formed flowed into the place of today's English Channel and emptied itself into the Atlantic Ocean. Doggerland even featured a lake. There were some glaciers as well, but the land was still inhabitable. So who lived there? There were communities of hunter-gatherers from the Middle Stone Age. This was the time of human history when our ancestors mastered chipped stone tools. They used these stones with sharp edges for spears and arrowheads. This came in handy at Doggerland, which was the richest hunting area in all of Europe. It could have easily been the most populated region in the northwestern part of the continent. The hunters' prey likely consisted of reindeer, mammoths, oxen, wild pigs, brown bears, wolves, and many other species. In short, nobody went hungry here. Meat wasn't the only thing on the menu. Ancient residents of Doggerland collected hazelnuts and berries. They lived in wooden huts. They built them close to rivers, and they even constructed their settlements on hills. Remember Dogger Bank? It now sits underwater, but it used to be a mountainous region. Doggerland must have been prime real estate in prehistoric times. Its total surface area was over 18,000 miles, but things were about to go under, literally. The last ice age was ending. All the water trapped in glaciers and ice sheets started to melt. You experience this process firsthand every time you order a cold drink. Even if you drink it bottoms up, after a while, the glass is full again. Why? Because the ice cubes have melted. Think of Doggerland as that glass. The sea levels started rising quickly. Every century, the sea flooded from 3 to 6 feet of dry land. Just imagine what this would mean today. Miami's elevation is just over 6 feet. The city would be flooded in less than 100 years. But there was one event that speeded things up. The Storegga slides were a series of submarine landslides in the Norwegian Sea thousands of years ago. And what happens when huge chunks of Earth shift suddenly underwater? Gigantic waves. You probably know what a tsunami is. Doggerland was likely pounded by several of them. They were so powerful that researchers believe they washed away Great Britain's land bridge to the rest of the continent. All that was left of Doggerland was an island the size of Wales. Scientists estimate that the waves of this ancient tsunami were at least 40 feet high. Some 6,000 years ago, Doggerlanders were on the move. They were migrating to higher grounds, England and the Netherlands in their case. The ironic part is that when we literally translate the name of the country of Netherlands into English, we get lower lands. But thousands of years ago, this was higher ground for hunter-gatherers escaping the flood. Once it was all over, the continent of Europe got the shape we easily recognize today. But Doggerland was nowhere to be seen. It's been sitting under the waves of the North Sea for 8,200 years. Does the idea of Doggerland remind you of a more famous case of a submerged land? The lost city of Atlantis comes straight to mind. But there is an important difference. Atlantis is only a legend. Everything we know about it comes from the writings of the Greek philosopher Plato. Scientists have been searching for Atlantis for a long time. And, up to this day, they can't even agree where exactly it was. Theories range from the Mediterranean to even Antarctica. Doggerland is not a myth. Everything science knows about this lost land comes from hard evidence. In 1931, a fishing boat was doing its thing off the coast of Norfolk in England. At the time, the crew would drag a net along the sea floor, sweeping everything in its path. And they caught something more than fish. It was peat, like the stuff we find in Alaska and in Ireland. But what was it doing at the bottom of the North Sea? It didn't belong there, because seawater destroys peat. There was only one possible explanation. The area must have been dry land at some point in history. The final proof was that the peat contained a harpoon spear point, a sure sign of human activity. The idea wasn't new, though. Since the Middle Ages, there has been talk of submerged land with underwater forests. In 1913, a British geologist came forward with the idea of an undersea world in this part of Europe. Scientific evidence kept piling up. Local fishermen started pulling out human-made tools and animal bones. Researchers dated them to be around 9,000 years old. But the deep, murky waters of the North Sea made it impossible to send down divers. One archaeologist noted that they knew more about the surface of the moon than what lay at the bottom of this relatively shallow sea. The discovery of oil in the area in the 1960s was a real game changer. Companies from the industry provided seismic survey data to scientists. This helped them piece together the full image of what Doggerland used to look like. Computer models soon produced images of river valleys, coastlines, freshwater lakes, and hills. There are even footprints of nomadic tribes preserved on the sea floor. Today, marine biologists are using magnetic fields to map out this lost underwater world. But Doggerland isn't the only place on Earth that went under the waves. Beringia is another lost world of global importance. This used to be a land bridge between Asia and North America. It got its name from the Bering Strait. It is 53 miles wide at its narrowest point. But until the end of the last ice age, this was dry land that our human ancestors called home. Genetic evidence shows that Native Americans lived in Beringia for some 15,000 years. If you want to imagine what this land looked like, think of present-day Arctic Alaska. It was a shrub tundra. There were also small willows and birches. Sorry, no woolly mammoths. Large grazing animals simply wouldn't have had enough food in Beringia, though there were probably elk and bighorn sheep in the area. But the Ice Age wouldn't last forever. Like in Doggerland, sea levels started to rise. This happened some 13,000 years ago. It wasn't all bad news, though. Scientific evidence suggests that around this time, people started moving south. They left the slowly sinking Beringia and crossed over into Alaska. From there, they populated both Americas. These were the ancestors of Native American tribes.
You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. but the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled. But all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.